Hello there, good morning, good afternoon, wherever you are. Welcome back. After building a new valve amplifier. Friend in Australia, Joe, built these really nice output transformers. We've got a primary of 3471, I think it is. So it'll be suitable for 4 EL34s or 4 807s, as I've got a lot of 807s and I keep meaning to build an 807 amplifier. Then I'm going to use 807s, but then and again I should build the amp so it can use EL34s, you know, if somebody wanted to. So got the output transformers, we need a mains transformer. Got this big bugger here that has 330, 0330 secondary, HT secondary on there. This is no good no, this is no good for 807s because 6.4 volts for 807s. An 807 is 900 milliamps each, so that's about 4 amps for 4, so that's no good, but maybe it could be used with a separate heater transformer. Well, I stuck a basically I powered it up on the mains, measured the secondary, then put some resistors on it till it dropped by 10% and listened to the transformer and felt it heat wise and whatever, and it started dropping with a load on there that gave a secondary output of 330 milliamps. I think that was with 2k on the as a load, so that's no good because for two lots of 4807 output valves with a quiescent of around 60 milliamps, do 1.5 times that, it works out that I need about an amp of HT. It's something like 720 milliamps, but let's call it an amp. So that is no good. So we're looking to repurpose this 500 VA toroid. So luckily it's already got the primary wound. So to get a HT of about 400 volts, we need, look at my fag packet back in the envelope calculations, blah, blah, blah. We need 282 volts secondary, because if you times that by 1.41 it'll give you your 400. This is unloaded, so after a lot of calculations basically I add about 50 volts onto that because I can adjust it when I wind it. So what I did to find out what sort of length we need our secondary, I wound 10 turns of wire on there, powered it up and measured it. So with 10 turns I got 4.38 volts. So times that, get 400 divided by 4.38, blah blah blah, add a bit on for you know, for it for loading and whatnot. And then basically we work out that we've got to have 71 times that 10 turns to get our 400 volts. But what I'm going to do is that I'll wind, instead of winding one long secondary, I'll wind a shorter two secondaries side by side and then join them in the middle, if you're with me. So hope this is making sense. I'm going a bit too fast probably for some of you. Instead of having a secondary like that, what we do, we wind two like that side by side and we just join them. When we do join them though, we have to make sure that they're in the right phase. otherwise this will get very hot and burn out. So anyway, I've done the calculations, measured the 10 turn winding, and that was 6 foot. So I've worked out that I'll need 210 foot, 2 times 210 foot. Add a bit on, make it 240, because of that, obviously when we wind this on here, there's going to be some extra, you know, you can't, we haven't got a machine, we're winding by hand, so you can't get it exactly the same. So what you'll see in a minute, I'm going to go on my local park and pace it all out and measure the wire and then wind it on these bobbins like this. This is one I did another time. As you can see, I'll put a bit of tape, I think every 10 foot. So before I do that, as you see, this has already got some insulation between the primary, but it's had, probably because this is used, it probably might be a few dinks in there, and I want to be absolutely sure, because obviously we've got a lot higher voltage than there was previously when this was wound. This had two 50 volts at 5 amps. So you can get this stuff called Captain tape off eBay, well you can in the UK, I think you can anywhere. It's about £5 a roll. So I'm going to put a layer of that over this secondary, and then I'm going to go and put on my heater windings, which I'll come to in a minute. Okie dokie. There's our transformer covered in Captain tape, so now we know that it's got good isolation between the primary and the secondary. I will test this at some point with a high voltage test. So I've wound 2 of these toroids before. The reason I did toroids was because I had some old toroids lying about. That was one, so they were cheap, so nothing basically. Secondly, it's easier if you haven't got a winding machine to wind these. It doesn't take long. Once you've done all your calculations and all the rest of it, it doesn't take long to wind these by hand. Thirdly, obviously a toroid has higher, what's the word? It has higher magnetic inductance, so that you need less turns to get your, you need less turns. This is not going very well, is it, Andy? You need less turns to get your voltage. Now in the past, what I've done, I've wound the HT on after the primary, but what I've found is that when and then I put on the heater windings, the big high current heater windings on last. The problem with this is that I found is that they have poor regulation, not so good regulation. So what I'm going to do, I'm going to put the heater windings on first. It's not going to be as neat, but hopefully then I should have better regulation. So as we only need something like 4 amps, 6.3 volts at 4 amps for the output valves, then we only need something like 15 turns, which isn't a lot, and so I'll put those on next. Now ordinarily I wouldn't countenance reusing wire that came off the transformer, but this is a low voltage winding, and it's good old thick stuff, so we'll be alright, I think. I've done it before, I've done it quite a few times and had no problems. So these are the windings that come off. They were the 50 volt 5 amp windings, so these will be more than sufficient for the heaters. So right, what I'm going to do is put you on a tripod. Okay, right, I changed my mind. I'm going to connect the heaters up in series rather than parallel for a few different reasons. It means that I can use lower gauge wire, which is a little bit neater. One of the problems I had as well was finding some stranded cable that was thick enough to take about 4 amps. Just didn't really have any. I prefer in series as well because it keeps the heater winding when you have valves in parallel. 4 valves, this will be in parallel. It keeps the heater winding neater. And the other reason was that this will be suitable for either 807s, KT66s, ER834s, but if I wanted to, what I should have really done was put a centre tap in here for so I could run 1625s, but in the eventuality I did want to run 1625s, then it's just a matter of probably just making up a regulated circuit to get me 12.6. Mind you, would this one go down? No, that would make it bigger, wouldn't it? Yeah, it gives me a few more options anyway. So I put on, I calculated that we need 25.2, which is 4 valves in series, so we need 25.2 volts. So divide that by our 4.3, which was a 10 windings, so we should need about 6 times 10, 60 windings, which is what I got in there. Put you up there, which I bet you can't see now. Hopefully you can see that. Come on, zoom in, mate. So we've got 23.7, so we're short. So I'll put on another few windings, and then what I'm actually going to do is to connect 4 807s in series and then test it. Because what I've done in the past, I've tested it with a resistor to give us, like, you know, a load, and then, you know, cut the thing, and that's it. And when I've actually tested it with the valves, I've found out that it's been low, so I'm going to test it with the actual valves. Anyway, more later. Right, I've put a few more turns on, and I was getting 26 volts or something like that. Got 4 807s in series. Sorry about this. Hopefully you can see that. I'm getting 24.9. So we need a few more turns. What I shall do at some point, alright, what's it there? Yeah, what I shall do at some point is put it on the variac and see how it is with the mains voltage, say 5 volts lower and 5 volts higher, see what regulation we've got. But I'll put a few in, I'll put a few more windings on and see how it goes from there. Right, 3 more windings on. 25.9, 26. What am I doing here? I've done this wrong, haven't I? I need to take some off because it was 25. Right, I've got to take some off. Tick box. Right, with a mains voltage of 240 volts, I'm getting 25.19 on the secondary. With a mains voltage of 250, which is possible. It's got to come down. Warm up. So you can see that. Getting 26.7. That's with a mains voltage of 215, which is possible. So where we got 26, call it 26.1. So that is 0.8, say 0.9, call it 1 volt over. 1 volt over shared between 4 valves. So that'd be 1 volt divided by 4, call it 2.5, 2.5 is that within our regulation. Our heaters have to be within 5%. Jesus, what's 5%? A bloody 6.3. So I either take a winding off or leave it. I'd rather it be high than low. I think I'm going to take a winding off and then see. Back in a minute. It's a bit of a faff, but it's the only way to do it, I think. I've taken a winding off. Where can you see that? 240 volts mains. Got 24.7, which is 0.5 volts under, with mains of 250. I've got 25.75. I'll call that a wrap at that. It's a little bit over and a little bit under. Before it was bang on when the voltage was under, but quite a bit too high when the voltage was quite a bit high. Right, so I kept count, but I also, I don't think you can see that, yeah you can, also marked every 10 turns. So we've got, what we got, where are you? Hiding 1, 2, 3, 4, 5, 6. So we've got 60, 1, 2, 3, 4, 5. We've got about 65 turns to get our heater voltage, which makes winding the secondary one, which makes winding the second one a bit of a lot easier, should I say. Right, I'll get that done and get back to you. Just before I pack up today, it's absolutely scorching inside here as it's a really hot day. I've wound a 6.3 volt winding, or should I say I've wound 2 of them for the phase splitter and drivers. There's enough copper in there to provide the heating power to either 2 6SN7s or 3 6SN7s. Anyway, an illustration of why I prefer, or one reason I prefer series heaters to lower voltage 6.3 volt heaters. The centre tap is a bleeding nightmare to get. So what we've got here, we've got 17 windings. So you'd have thought like this one in the middle would be half the voltage. So basically what I've got here, I won't power it up, but I have 3.2 on this side and 3.6 on the other. So you would think that if you just move round a bit, then you would get less voltage. And that's not the case. Basically it only drops if you go one winding over. So, but if I go one winding over, where I had 3.2 here and 3.6 here, now I've got 3.2 and 3.6. So it's impossible, as far as I can see, to get a perfectly tapped centre tap. As this tap is only here so I can elevate the heater windings, then I think what I'm going to do is what I did on the last one. I'm not going to bother with the centre tap. I'm going to do what I did on the last one, and that was to use two 250 ohm resistors and then just tap it from there. It's a lot easier than buggering about with this centre tap. So I'm going to put some varnish on there, cover it with tape and call the job done. So I've already wound this 3 times, on, off, to sod it. I'm buggered. Anyway, I'll turn off and we'll do some more in the morning later. Right, here we are again, 2, 3, 4. A bit of a late start this morning. I had to go to the doctor's, got something stuck in my eyeball. It's a bit of a late start. So last night I was a bit knackered when I finished. I finished the 6.3 winding, which was supposed to be centre tapped, but I think the problem is because this toroid or core has a higher flux density, then it means that obviously there's more voltage per winding, which also means that you haven't got so much flexibility either way. So say if this was an EI core, what did we have yesterday? We got, was it 17 turns or something like that? Probably on an EI core you might have, say, 25 turns, say, just off the top of my head. In which case obviously you can get the tap a lot more accurate. But as this is only for elevated heaters and we're not bothered about hum really, we just stick a couple of resistors on there, or you could even use a pot. So anyway, that's the bias winding that I've just put on, which is 190 turns to get 84 volts, and it's 52 ohms resistance. So what I'm after is about 100 volts DC. So this should give 120, but because this is only a thin wire, it's only what, 30 milliamps capacity, something like that. And because of that resistance, a high resistance there, it's going to drop about 20 volts. That's just from experience. I mean, if you was to be winding this yourself, then it might be well worth sticking this on a bridge rectifier or something, and you know, to get the actual voltage that you need to make sure. Again, I'm waffling. So now I'm going to put a layer of that Kaftan tape wherever it's gone, seal up these heater windings and the bias, and then I'm going to wind the secondary. But before I can wind it, I've got to go on the park and pace out, measure out the wire, or I could just make a foot long doodah thingy, what's it called, bobbin, and then just wind it on that and just count. But yeah, I don't know yet. See how we go. Might be nice to get out in the sunlight. Ho ho ho. Later. Okie dokie. We're outside. There's the workshop, which has a sort of plasticky sort of roof. It's really hot in there. Too hot to work. It's like a sauna. I've been on the park, put the winding on a bobbin, as you can see. So you can't see. Winding two. Can you see that? Winding 2 windings at a time. This is 63 mil. What is it? 20? Can't remember. 24 gauge or something like that. Or is it lower than that? 23 gauge. Capable of carrying 1.2 amps, I think. So that's more than enough for our 720 milliamp winding. I've covered the heater windings in a layer of Kaftan tape, and for good measure I've put some of this black horrible stuff on, but it will add some more insulation between the high tension, the HTB plus winding and the rest. Right, just got to put, I think we've got to put on 37 times 10. So 370 windings. Right, let's crack on. There we go then, third day. That's the HT winding on. We've got, what we get, 150. Right, these two here is 150 volts times 2. That'll give us about 420 volts ish at about 1 amp. And then this tap here, there's a load of extra windings on there, will give us about 450 volts, maybe 475. I'm not quite sure what it'll be till I actually put a load on it. So I've got a heater windings, bias, HT, B+, primary. So put a layer of capstan tape on now, probably put 2 on actually to isolate this, and then I might put a 12 volt winding on there, which is useful for powering things like protection circuitry and what have you. I'll get that done, and then that's about it, right, lads and lasses, should I say. Later. Right, just to finish off then, I had filmed this before, but I foolishly deleted the last bit of video clip. So I've wound the transformer. To reiterate, to repurpose a toroidal transformer, you can buy basically off eBay, say a used toroid that's wound for your country's voltage, in this case the UK, which is nominally 230 volts, but actually the mains here is 245-ish. Take off the secondary and then wind your own secondaries for a valve amplifier, say, as long as you keep within the core's ratings, in this case 500 VA. So what I did, I took off the secondaries, revealing just the primary. I reinforced the insulation on top of the primary. Then I wound 10 turns, it doesn't matter what gauge wire, just 10 turns of any gauge wire, 10 turns of wire onto the core, and measured its voltage. And then I took that winding off and measured its length. So that now gives me a voltage and a length for you know, that wire, so I know how much flux density, I think the word is, that this core has. And then it's just a matter of working out from there. So for heater windings that are on AC, we don't need to do any jiggery pokery. So the first heater winding I did, which was for 4 807s, it's just basically 4 times 6.3 volts, because I'm wiring them in series and not in parallel as is usually the case, which gives us 25.2 volts. Put the windings on, and then to test the regulation, I put it down to 240 volts and up to 250 volts, and either took windings on or off, put windings on or took windings off, to get, you know, nominally 25.2 volts. If you look at most transformers that have got heater windings on, they won't be exactly 6.3. As long as you're within the about 5%, you're fine. So I did that, and then using the same sort of methodology, I then put on a HT winding. But to save having to wind lots and lots and lots of turns, I basically wound onto a bobbin 2 lengths side by side of the wire, and then as I'm winding it on, I'm just putting a little twist in it to keep them both together. So each winding is coupled to each other, capacitively, inductively, but also magnetically. So you basically end up with 2 windings of identical voltage and current. And then basically what I've done here is I've joined them there, and so I think I had two 150 thereabouts volts AC. Join them, that gives us 310 volts AC. Once that is rectified, you times that by 1.414, and that will give you a rough voltage. This is never exact, because when you actually rectify it, like say here with the bridge rectifier, you've got a voltage drop of the actual diodes and you will lose some. So you have to jiggle it about, because also your voltage that you get out of here with no load will be different to a voltage with a load. The other beauty about winding your own transformer like I've done is that you can overwind it, which means that you're wiring it a thicker wire gauge so it has more current capacity, and also that means that it's got better regulation. A lot of transformers, especially on guitar amps, are underrated. So when you when you turn it up to full volume, it will sag. The B plus or HT will sag. It will, in other words, it will drop some voltage. Winding your own, this won't happen. So this is really good for a hi-fi amplifier. You want it to be linear as possible. By linear, that means that it doesn't change. Right, I hope that makes sense. So the last test I'm going to do is using this old AirMech ionization tester, and basically what it is a mega, but it also, yeah, it's a mega basically, so it tests the insulation resistance or resistance of anything, a capacitor or whatever. And what it does is basically put in a very high voltage, either 1000 or 10,000 volts variable, and it's basically it's listening to the insulation. It's got like an amplifier, you'll see in a minute. So I've got one side connected to the primary, that's the earth, and then this is our high voltage lead. Put it on the right setting, 200 volts, got it on the wrong setting there, 400 volts, 800 volts, 1000 volts between the primary and the secondary. Click that off, bring it on to, if I can just get in there, put it on the 10,000 volt setting. So now this will be 2000 volts, 4000, 6000, 8000, etc. We should start to have some insulation breakdown there. Come on up you come. 1500. 2000 volts. We're trying to listen for clicks. And there are no clicks, so that's pretty good. This the insulation is good to 5000 volts, which is more than adequate for our purposes. And we can test the insulation breakdown between the heater windings and I'm just getting the screwdriver, heater windings and the secondary. So now that's the heater windings to the secondary. .6,000 volts. so that's fine. So now I can get on with building the power supply and building the amplifier, which I'll do in the next video. Thank you very much for watching. Hope you learned something. Hope that helps you to wind your own toroid transformer by hand in the future. Thanks again. Ta-da now.